Hello everyone, do you hear me well? Excellent. So we're a small group of people, but anyways, hope you like what we have to tell you today. Did you see the keynote live demo this morning about VR? So we're going to talk today a little bit more about why we went VR, why we're doing 3D data visualization, and how we think this is the next generation. This is the natural evolution of visualizing data. The agenda that we will cover today, we will first talk about what is data visualization. Then we will talk about data visualization in doing data analysis. Then we'll talk about specific aspect of data visualization, 3D plots. Are they good or bad on 2D displays? Then we'll cover a very interesting technique called stereoscopic 3D. This is the technique behind 3D theater movies. I guess all of you have seen 3D theater movie. The 3D there is realistic. Then we'll go back to 3D plots, but this time on 3D displays, having in mind the stereoscopic 3D, the virtual reality. It uses stereoscopic 3D, and we'll see if it is a good thing to do. And then we'll show you some live demos. An important note here to make, everything that you see on the 2D screen, even the demos, will still be a projection of a 3D experience. So if you want to feel the 3D experience, you need to put the device on. So let's start. What is data visualization? By definition, data visualization is a type of visual communication where information or data is set or displayed by using visuals or a pictorial format. Our brains, during the whole evolution of mankind, our brains are extremely specialized in processing visual information versus processing text. Text, for example, is processed 60,000 times slower than visuals. Why is that? Because text is first an algorithmic representation of encoded data, encoded information. It is processed on the short-term memory of the brain, and the processing power of this short-term memory is somewhere between 4 to 7 bits, so it is extremely slow. Compared to visual communication, visuals are processed directly on the long-term memory, and the computing power there is unlimited compared to the short-term memory. Some examples of using visual communication today. We're so much used with visual communication that we don't even think that it is actually visual communication. For example, road signs. Imagine all of these signs here communicated through text instead of visuals. So your brain virtually will not have the power to process all the signs simultaneously. Here, this happens instantly. You can process all the signs immediately, primarily because this is a long-term memory process. Another very good example of using visuals or visual communication, icons. Literally every piece of software today uses icons in some form, be it a desktop icon or a toolbar icon or a context menu icon. Everything uses icons. Icons on the web, icons on desktop, mobile, and so on and so on. This is visual communication. Another good example of visual communication is brand logos. Why brands are using logos? For exactly the same reason. Logos make a long-lasting memory directly in the long-term memory of the brain. So it is extremely easy for the brain to make this association of a brand name through a brand logo, through the image. And I put this picture on purpose just to demonstrate that visual communication originates from the very early ages of humanity. This is a picture from caves that dates back 35,000 years ago. Even that time, people used visual communication. And now, using the power of visual communication for doing data analysis. Today, when we say data visualization, oftentimes we implicitly refer to this as doing data analysis through visuals or graphs or plots. There are two types of data, qualitative and quantitative. Qualitative data is any property of an object or a living creature that is non-countable. Quantitative is the opposite. Data visualization is the way that we take data properties, present them through different sets of visuals, and form a final graphic that demonstrates qualitative and quantitative properties of the data in a meaningful way that provides the brain with much easier understanding of what's behind the data. For example, if you take a simple chart and compare it to a simple grid, for example, spreadsheet that you only have the textual data there, compared to a bar chart, what's the better way to present our data and do some data analysis? Obviously, the visuals. This picture originates back in 1812. It is created by Charles Joseph Minard, and it is one of the first pictures that use visual communication to do data analysis. So this is the Napoleon march towards Moscow. The color of the lines represent the direction. The beige line represents the march toward Moscow, and the black backwards. The width of the line represents the total number of soldiers. So we can very easily, within less than a second, we can have a grasp of what happened with all the soldiers that marched toward Moscow and how many of them returned back to France. Another very good example of data visualization in history, this is the so-called Nightingale rose. It is a data viz technique that is used successfully even today. It is created by Florence Nightingale in 1850. I will not go in deeper detail. It's a more complex graphic here. And this picture is actually a screenshot of that visualizes most of the common charts and data visualization types that exist today. Today we have dedicated software tools like, for example, Microsoft Excel and Tableau that help us just by feeding them with our data to quickly produce visualizations that then we can communicate with other people and also do analysis ourselves. And now this specific aspect that I mentioned about doing 3D plots on 2D displays. Don't go 3D. This is the name of a whole chapter of Professor Klaus O. Wilk, who created a very solid data viz book. It is called The Fundamentals of Data Visualization. And that's the name of the whole chapter. Actually, the Professor O. Wilk demonstrates that doing 3D plots on 2D displays is most often a bad thing to do. Why is this? Because, for example, if you look at this picture, the data in its nature here is two-dimensional. The 3D projection here, or the 3D plot, is nothing but a decorative addition to a simple 2D plot. And this is something that some people may consider more visually appealing or more delightful, if you wish. But the truth is that the projection that happens of 3D objects or objects that are three-dimensional, when they are projected on a 2D screen, they go through a transformation matrix that skews and distorts data so that the brain is tricked that although the brain looks at the 2D picture, there is some sense of depth. But this transformation distorts data. For example, if you look at the first bar here, and you can quickly tell that the total number of passengers that fly first class is somewhere below 300, right? But the truth is that the number here is about 350. And this is the data distortion. Because of the 3D projection, our brain cannot reproduce the 3D scene, and this is bad or wrong representation of data. The very same data seen on a 2D plot looks different because of this projection. And this is decorative 3D that we definitely should avoid. Another example of why 3D is a bad thing to do on a 2D display. I emphasize here on a 2D display. Again, this time the data in its nature is three-dimensional. It has properties that can be mapped to real-world coordinates like X, Y, and Z. But if you look carefully, it is very difficult for the brain to actually determine the position of each point in the 3D space, in the real-world space. You cannot tell, but just by looking at these points, what are the X, Y, and Z values. Why is that? Because in this plot, data goes through two different transformations. The first transformation is data values are mapped from the data space to three-dimensional objects, in this case points. And then the second transformation transforms them back from 3D world objects to 2D points. And this second transformation is simply non-invertible. Why? Because mathematically, if you think what is a 2D point in the 3D space, it is actually a line of points. And our brain is so powerful that it tries to reconstruct the 3D pictures. But this is a highly unreliable process and highly dependable on additional depth clues. For example, if this graphic was rotating slowly, even on a 2D display, we could kind of reconstruct the position of each point. It still will be difficult and will be highly depending to the potential of each brain to reconstruct 3D scenes. Another example of why 3D is a bad thing to do. Again, this time, data looks like it is a perfect candidate for a 3D plot, but the very same rule with data distortion applies here as well. So, don't go 3D. And we are perfectly fine with this statement, but when we talk about 2D displays. And now we will talk about a specific technique. My colleague,
yes, I'll take it now.
We'll talk more about it.
So, if it is such a bad idea to make 3D data visualization, why are we talking about it at all? So, let's see what the stereoscopic 3D technology changes and how it is different from the simple projection on a 2D screen. First, let's make some example in how we see the objects in the real world. So if we make an experiment and place our hand, for instance, in front of our face and close, for instance, the right eye, then we see one hand. If we close the other eye so that we see with one eye, again we see one hand. And if we quickly switch between the eyes, then we may see that the image is moving left or right. So there is offset between the images that we see with the left eye and the right eye. And this is because each of the eyes has slightly different position in space and sees our hand from different angle. So our brain has such functionality that it manages to combine these pictures into a single picture. And what's more, if you place your hand far away or close to your face, then you notice that when it is closer, then the difference between the two images is much bigger. So this information allows the brain to add an additional depth information about the image, so it can see that the hand is closer or far away.
Yeah, just to add here, the interesting part is that each of our eyes sees in 2D. So the image that each eye gets is a two-dimensional representation of the real world.
Yes, it's projection on the retina, actually.
Yeah, and it is the magic of our brain that takes two images together, calculates the offset, and creates this realistic sense of depth. And we see the world in 3D.
So this stereoscopic 3D technology actually is based on this functionality of the brain. And when you put a VR headset like this one, you actually receive two different images for each of the eyes. And the brain manages to combine these images, and you feel like in the real world, feeling the depth of the object. So this is actually the most significant difference comparing to just projecting the 3D object into a single 2D screen. So here on the next picture, you might see an anaglyph 3D. This is actually one picture that combines two pictures. So if you filter this image with different colors, usually these are chromatically opposite colors, for instance, red or cyan, then putting the red color on the left eye, it gets the image for the left eye, and putting the other color for the right eye, it gets the other image. So we can, it is actually the most common compression for preserving stereoscopic images. And this way we preserve both images into a single one. So you may see this in cinemas.
Yeah.
Yes, and when you put the glasses in the cinema, you become seeing the objects like with different depth. So how does 3D data visualization actually looks on 3D displays? In the same book that Georgi mentioned, Professor Klaus Wilke says that the rule "don't go 3D" actually doesn't apply to real 3D space objects or to stereoscopic devices. So if we have, for instance, a printed 3D model, then we'll be able to see it in the real world with the depth functionality, and we can even slightly move and see the bars, if, for instance, these bars are printed from different angle, and this way we can easily recognize which is higher than the other, and this is much different comparing to the simple 2D projection. The same is with the stereoscopic displays like this VR headset. So with them you're feeling like you're seeing actual 3D objects. So actually 3D data visualization is not such a bad idea when we are talking about real 3D visualization. So here is one example, a comparison between 2D data visualization and the corresponding 3D visualization. What is visualized here? We have several products that are being sold for some period of time. In order to visualize this in 2D, we have actually three dimensions: the time that the products are sold, the amount of the sale, so it's, let's say, in dollars, and also the third dimension are the different colors. So this graphic here on the left shows each color with a single line in which is colored differently. So each product is colored differently. So we can easily see that the top selling product is with dark blue color, the line above. However, looking down, we can see that there are a lot of products with closer selling values. So they're overlapping, and in this 2D visualization, we can hardly see which is performing better than the other. However, if we do this in 3D, we can look at the right side of this screen. Then we have actually three dimensions, so we can place the products and the time on the bottom plane, and the vertical axis may become the sales volume. So now nothing is overlapping, and if we see this on an actual 3D space or with such device, then we'll be able to move and see which bar is bigger than the other. So although this example seems on this screen similar to the previous examples that Georgi mentioned with don't go 3D, seeing them with stereoscopic device is much different.
Yeah, actually, this picture on the right makes a perfect explanation why we shouldn't do 3D plots on 2D display. It looks distorted, right? But if you see it in VR, it's a completely different story.
Okay, so here is the next example. Here we actually have a four-dimensional data visualization. On the horizontal plane, we have the time and the sales volumes, and on the vertical axis, we have the profit. The fourth dimension are the different products that are colored with different colors. Having real 3D space, we can allow to add even fourth dimension, while in 2D, this will be really difficult to visualize because we have not enough dimensions.
Not that it can't be done, it can, but the typical approach if we are to plot this four-dimensional data on a 2D display or 2D plot is to use multiple smaller visualizations that when combined, make sense of the third and the fourth dimension. So it can work, but given that we have the 3D space, it is much easier, and to us, it makes a lot of sense to use the real third dimension and use it properly to encode data.
So in the next example, we may see simple 2D visualizations. So how do we benefit from the 3D space here? Actually, if we want to show all these graphics on a 2D display, we are limited to the number of pixels on this 2D display. So we can hardly see all the graphics at once. So we have to switch context, change different windows, for instance, or something like that. While having the 3D space, actually we have the biggest screen to plot. So the biggest screen is the world around us. So we can place the graphics around us and see them easily just moving our head with a glance.
Yeah, imagine this room filled with charts on the walls, some 3D plots, in a way that makes sense to the viewer, of course.
So here, the bigger space is another benefit of the 3D visualization. And here is the last example we have. It is actually an example from one of our demos. It is a Twitter graph. Seeing it on a 2D screen, you may see that all the lines are intersecting. You can hardly say which node is connected with the other. However, having the depth with the VR headset, this is really different, and practically no line is intersecting the other. So this graphic can be read really easily in real 3D. So you see it later.
Yeah. Let's go with the demos. We are several minutes behind. Okay, next slide, Dino. So we're going to show you first our sales dashboard application. Some of you may have seen it at our booth. It is all about showing the potential of 3D for visualizing white data or multi-dimensional data. This is sales data that is made anonymous, but the schema behind the data is a real one. And what we will see here are 18 different dimensions of this sales data. The very same data is visualized in Tableau by 9, if I'm not mistaken, 9 different dashboards. So we'll see all the data here at once and take the bigger picture of the pulse of our business. Okay, so let me start the application. And the other thing that we're going to show is how collaboration feels like in VR. So me and Diana are going to join one and the same virtual room. and observe and analyze data simultaneously, sharing insights. Okay, let's see. The controller now works. Not like on the keynote demo. Purely magic.
So we have to play it on the screen.
Okay, so I'm in. Are you coming, Dion?
Yes.
Dion, something happened with your avatar.
Yes,
You're dead. Your neck broke.
I have to switch the screen.
Okay. Yeah.
So. We have to stop the presentation first.
I forgot that part.
Yes. How do I stop the screen?
Escape.
I tried, but not.
Software. So we stop presenting.
Yes.
And now we are in the game.
So this is a virtual conference room, and we are both in this room.
You are alive now.
Yes. Hello.
Hey, Dion. So I'm going to do a quick overview of what are the different dimensions here of data. The big 3D bar plot in the bottom left is showing 3 dimensions of the data. X-axis displays multiple products. As you can see, we have more than 20 different products. The Y or up axis displays the sales volume. And Z depth axis displays the date range that we are observing. The interesting part here is that the Y axis has 4 different scale breaks. Why is this needed? Because the top selling products versus the worst selling products, the difference in numbers is exponential. And if we are to plot all the data on a single scale, then most of the bars will be insignificantly high. So here on the right 3D bar plot is the same data, but this time we show the regions, sales by region dimensions. We have on the x-axis we have the regions, on the y-axis we have the sales volume, and again the depth axis is the same. It is shared between the 2 3D plots. On the top we have 2-dimensional plots. This plot is showing an aggregate function, sum or total of all the sellings for all the products, for a single product for the entire date range that we observe. So we can see here that the top selling product has generated about $2.5 million, and we also have encoded another dimension here. It is the sales type, expansion versus new versus renew and services. If I rotate the chart like that, on this 2D plot I have another aggregate function, but this time it is a correlation or intersection of the total of all products for a single month. So for example, looking here, I can quickly see that November 2017 has generated nearly $500,000. And the other dimension that is encoded here is the touched versus untouched flag, basically meaning if a salesperson has touched the deal or not. The same thing here is applied for the regions plots. The 2D charts represent a total function, and another encoding is again expansion versus new versus renewal versus services. And the same thing applies here for all the sales for a single month distributed by regions. We can easily see that North America is the top selling region. Well, that's from me. Dion, do you want to show me something?
Yes, I have noticed something. Notice this product, I think it's 20, yes. This product 20 has really insignificant sales all months except January. So, well, maybe it should be analyzed what happened this January.
Yeah, I see.
Can it be repeated somehow?
There is a huge spike here. Let me just take Can you point me to the total sum on the 2D plot of this product? Let me just take control.
Okay, take control. I didn't understand.
Taking control now. Here it is. So the total of this is 1800,000 and 16 of them are generated. When is that? January 2018. Okay, yes. So this is definitely something that we need to analyze. Probably it is an event that happened or a marketing campaign we need to see. And yeah. Okay.
Yes. Another thing I've noticed here, looking at these aggregated functions, then we may see that the percentage of the expansion in all regions is really low, except from North America. So maybe we should see what is done there to achieve such higher percentage, and if it can be applied to other regions as well.
Well, excellent insights. Thank you, Diana, and bye.
Okay, bye. You have to see the other demo.
Yeah, we are heading off to the next demo. So quickly.
So again, if we want to see this on 2D, we have to switch really a lot of windows. So we cannot see all this data at a glance.
Yeah. And the next demo that we're going to show you is the Twitter graph.
I just have to put the headset here.
I will talk while Diana is preparing with the bigger brother. So because of this brother, we have this gaming laptop here. So what we're going to see is our Twitter graph data visualization. It demonstrates what we talked earlier, that graphs are perfect candidates for visualizing in the 3D space, so that we can follow the best practices for visualizing graphs. Again, these practices are nodes should not overlap and lines should not intersect or edges. Okay, so now I'm starting the VR experience. So, Diane, you're in the game now.
Yes.
Prepare yourself.
I am.
You can move a little bit back.
Yes.
I think this is enough. This is enough so that we can be. And the other thing is, please keep in mind to stand still, because otherwise the screen is shaky.
Yes.
And it is not the best thing to.
Okay, so do we see?
Not yet.
Screen?
I'm just putting you on screen. You're live now.
Okay, so what we have here is a search bar, so we can write some Twitter account, for instance, and see all the latest tweets that are related to this Twitter account. We have also predefined such accounts. For instance, I can click here on Progress Software. Now we are loading live data, the latest 700 tweets from internet. And we are going to lay out them in a graph in front of us. The nodes in the graph are the people who have tweeted, and the edges are the connections between them based on how they tweet about each other, mention each other, retweet their tweets, and so on.
Sorry for interrupting. We picked this use case because Twitter, social network, is the perfect candidate for graph visualization.
Yes,
yeah,
exactly.
And we can easily see how the activity goes around a specific account. There is very few visualizations of Twitter that can show a meaningful statistics.
Okay. So we have here some 2D charts that say what are the most tweets for the least connected users and most connected users. If I get closer to the graph, I can teleport now. I become seeing the pictures, the avatar images of the Twitter users, which are closer to me in this graph. So here I can click on someone to see if he has tweets. For instance, this Twitter account has no tweets, but is mentioned twice, and that's why it is here in the graph. Here I even managed to find myself. I'm not an active Twitter user. I have just one mention. I've been mentioned once, and that's it. So yes, here is my colleague Panayot Tsankov. He is now at MS Build and has tweeted about his experience there with Microsoft HoloLens.
He is spreading the VR love, but at Microsoft Build.
Yes. So let's move around to see if we can see something interesting. So in the center of this graph, there is actually the Progress Software account, because that's how we build the graph. And the users that have less tweets, they are far away from the center. So this way we guarantee that there are minimum intersections of the lines in this graph. So here Kalin Tudorov, he's more active than me for sure. He has 3 tweets, more tweets actually. Let's see what's the number of his tweets. He has 1 tweet, 4 retweets, and 7 mentions. He has tweeted for Terraleak, that's why he is connected to Telerek's account.
Well,
and
I think that
so on.
You got the picture.
Yes, if you want to see how the communication is going on some Twitter account, you may explore this graph with the VR, because on the 2D screen there are too many intersections and you cannot see anything actually.
Yeah, and I'm going to stop the application now so that it is not shaky. Okay, going back to the slides. I'm going to make the same note again. If you would like to experience the real power of 3D, there is no way for us to demonstrate it on a 2D display. You need to put the device on. Otherwise, you're seeing 2D projections of real 3D experiences. You can drop by our booth. We will be there tomorrow and probably later this evening. So if you're interested, you're welcome to try the experiences. Well, I think basically this is what we wanted to share with you. A brief overview of data viz, visual communication, data viz for data analysis, why 3D is a bad thing to do on a 2D display, but it is a completely different story when we talk about 3D plots on real 3D environments, in our case, stereoscopic 3D. And with that, thank you. And so we have some time for Q&A. Any questions?
So how far into your roadmap before so we can connect to a data source and bring in the graph and set up a scenario? Is that where this is going?
So you are asking if we have some data connectors behind the visualizations, right? Well, there are a very straightforward path for us to take. This is Progress Data Direct with multiple connectors. We can basically consume data from anywhere. We will most probably integrate with Data Direct, and then we'll do some data shaping and modeling support so that people can pull data and extract data columns that are meaningful to them, and probably add some aggregate functions on top of them, and then see the whole thing in VR. We have plans in our roadmap, but it is still tentative and not set in stone. Yes?
Can I reshape the same question? Like, I have Progress database so that I can a huge application running. I have a bunch of devices. So how I can easily, deploy them, put it to my managers, on my manager's table? Do you have like some application ready to go that I can connect to my database and start slicing and dicing? Or how do I view the report? Looking at something like
That's a very good question. What you just saw is what we call the MVP, or minimal viable product. So we want to validate with people that 3D plots make sense to them, that resonate well with clients with more complex data. And if you wish, we can work together and make the whole path.
So
As of today, we don't have this.
in other words, the answer is no, but you go in that way.
Our vision is that we will go that way, and this will make the story more complete. This will make it a product.
So is the vision to the end goal, in essence, that VR, Power BI, the platform, in essence, I mean, that would be amazing if we were in that way, investing in it fully.
Ultimately, yes. So your question is this a tool like Power BI our end goal? We will try not to strictly follow what Power BI is. We will try to make an integration with Progress tools, so that our Progress customers can take advantage of 3D data visualization. And we will see what's the best way to do this. But we do not want to compete with tools like Tableau and Power BI. So most probably we will make some extensions on top of these tools. And we will make some visualizations that will work with our Progress products.
So people are already using like Tableau and other things.
Yeah.
If they plug in your tool,
Exactly.
you can extend.
Yes, we don't need to rewrite the whole logic, just need to add the additional visualization of this logic.
Yeah.
So can you, if your friend is in the other room or in another city, can you still connect through?
Your question is if we can make remote connections without being physically in the same room. Yes, it is possible. We have the voice over IP support. We intentionally switched it off because we are physically in the very same room, and it's not going to be a good thing to have voice over. But yes, we have it. If we are in different rooms, all we need to do is to make sure that we are on the same network, so that the server IP is accessible. For now, this is the requirement. Probably at some point we will go HTTP or through some service. We'll do the networking, but yeah, we can do it.
We have such implementation with us actually now in this device.
And you have a demo working with it.
Exactly. Yeah, this is a barcode of our web page where the 2 demo applications that you just saw are available for download.
I can see it in my.
Exactly.
Yes.
All you need is Unity so that you can build and deploy to your Oculus device. It will work on Rift and Oculus Go. Other questions? I hope this vision makes sense to you, that 3D on a 3D display is a good thing to do. Well, thank you then, guys. Thank you for being here with us today.